Alright, hello everyone, this is Mr. Crozier. I want to give you some help studying up the pictures for practice test number 3, the vector word problems. Number 1, a pilot leaves an airport with a bearing of north 60 degrees west. So first thing we want to do is draw our coordinate plane, and we have north, east, south, west, and we're going north 60 degrees to the west. So this is 60, this is 0, 90, 180, 270. Now those are not the numbers you're going to need on your calculator, but those are the numbers for the bearings. North, 60 degrees to the west. So you want to put a protractor on here and count 10, 20, 30, 40, 50, 60, and make a direction to the west. 60-degree turn to the west. And this is the plane, and the plane speed is 450, and that's how I like to write it. So then now we have the wind. There's a wind at 50 miles from the due south. So from the due south, the wind is blowing up this way. And I usually make the wind bigger, and it's 50 miles an hour. And where's the plane? Well, if you take this little vector and you put it right here, same place, now you can connect the lines, and now you can see exactly where the plane's going to be. That's going to be the plane. The plane is going to be sped up, and the vector, or the angle, is going to be reduced. It's not going to be a 60-degree turn, it's going to be a little bit shorter. So it's going to be that one right there. And it's going to be sped up a little bit, right? Because it's going a little bit faster. It's pushing it. It's going to be those answers. So those are your two answers for the first one. Now what you want to be careful about when you're doing the plane vector, and you're obviously going to add on the wind to get to the resultant, the plane vector is 450 cosine angle, comma, 450 sine angle. However, what is this angle? Your calculator does not recognize those degrees. Your calculator only recognizes this is 0, this is 90, this is 180, this is 270. So your calculator is going to look at this plane from 0 to 90 to 60, 150, 150. So you have to be real careful here. This is the bearing, but that's what your calculator is going to recognize. Do the same thing for the wind, add them up, get some components here, an x component, a y component, and use either the magnitude or the inverse tangent. Number 2, the sled dogs have gone mad. They're pulling this sled in 4 different directions. 15 newtons due east. Well, this is north, east, south, west. Due east, 15. Due south, 12. Due west, 13. Due north, 18. You have 4 vectors, add them up, get the resultant. Or wait a minute, let's do a little bit of thinking here. This is 18 and this is 12. So if I put those together, there's only a force of 6 to the north. This is 13, this is 15. There's only a force of 2 this way, to the east. So now you just have 2 vectors, and this is a right angle. So you could use SOHCAHTOA if you could figure that out. Number 2, 2 forces are acting upon an object. One's at 50, one's at 90. There's my 2 forces playing tug of war with this object. 50, 90. The angle between them is 40. So I might as well just call this one 0 and call this one 40. It doesn't matter what we call them because there's no reference here, just as long as there's a difference of 40. Add the 2 vectors, get the resultant, and then use it from there. All right, on the back, same thing here. We're going to draw a plane, and we have north, east, south, west. 0, 90, 180, 270. These are bearings. This is not what your calculator is using. Those are bearings. All right, a plane starts with a bearing of 65, so take the time to put your protractor on here. 65 is right there. That's where the plane's going. Plane. 500 miles an hour, 65 degrees. However, due to the wind, the plane is actually flying only at 60, so really the plane's really going here. But it's going 550, so 550 is longer. So maybe it looks like that. And your job is to find the wind. Well, obviously that's the wind right there. The wind blew it from there to there. All right, so what do we do? What do we know? The plane plus the wind equals the result. But I need to find the wind. So let's take away the plane vector. Gone. Wind is equal to resultant minus plane. Set that up. The resulting vector minus the plane vector equals the wind vector. And again, you're going to have to do this kind of work here. And we can go ahead and fill this in. What is the resulting vector? 550 cosine of something here. Not sure what it is. I'm going to let you figure that out. And 550 sine of something. Can't use these. Can't use 65 and 60 because those are bearings. Your calculator does not do bearings for you. All right, a yacht is cruising at 20 knots. Again, at a bearing of 185. So let's go ahead and draw that. This is 180. And this would be 270. So where's 185? Well, that's 5 degrees past here, so it's right there. Here's the yacht going at 20. The current starts. Well, the current's 5 knots at a bearing of 270. Well, 270 is here. Let's see, 20 degrees. Take the time to put a protractor on here, up here. So there's my current. And I always make it a little bigger. Yacht, current, do the math. All right, you push a box with a force of 500 newtons directly north. All right, we have another one of these. 500 directly north. So I'm going to go north 500 newtons. Another person pushes a box with a force of 800 directly east. Well, let me make this a little bit longer so it reflects that it's 800 and not 500. 500, 800. What is the resultant? Well, where is the resultant? Well, I take this vector and put it over here, and right there is the resulting vector. It is 800, 500, right angle. You could use SOHCAHTOA because we have a right angle triangle, or you could add the two vectors and do it that way. Either way, this way is going to be easier because if you want the resultant force, that's just this. A squared plus B squared equals C squared. If you want the direction, you can find that angle by inverse tangent right there. All right, hope this helps you set them up.